Aloha, Richard Halverson here. This is ITS128. And today I'm going to finish up the chapter on classes, starting with class constructors. Let me share my screen. And in the syllabus, we are the video I made earlier today and today's video is going to finish up classes. And I have started chapter 10 already. I did that last week. And so we will, not this video, but the next video following this video will be continuing on with chapter 10. Where we left off with the last video was I covered chapters 9.1 and 9. Up through 9.5, and you should probably scan through those because it's all stuff you already know, but it's attaching terminology to it. We're used to using classes. We create instances of classes, and we have strings, and there's methods. Dot. We have lists. We have methods like dot append if we're going to add something to the list, and so on. But with Python, you can make your own classes. You can define your own data types. And so that's what we're getting to in chapter 9. And so we've covered 9.1 to 9.5, and we've done lab 9.11. Today, we're going to finish up 9.6, 9.7, and maybe 9.8, and a little bit of 9.9. We aren't going to do too much of operator overloading. Maybe in future, maybe in 148 or 228, we'll do more of that. And then you should go through, there's points to go through this memory allocation and garbage collection. That all is what happens underneath. In Python, you're creating objects and you're assigning names to objects, and you reassign things, and objects can be dereferenced, in which case there's an object out there that exists and it's taking up memory space, but there's nothing referring to it. There's no reference to it. And that's called garbage in memory, in a computer programming terms and compiler terms. That's called garbage. And there's a garbage collection phase which collects up all the garbage and returns it back to the pool of memory that can be used again for making new objects. That's all underneath, and that's all in this memory allocation. You should go through it so you understand it, but you're not really ever going to have to, there's no skills associated with that topic. All right, so we just finished this 9.5 in the last video, and in this example here, we create we define a class called seat. Okay, so the scenario is it's an airline seat reservation system, and we have this airplane that's got 5 seats in it, and a seat is an object that contains a first name and a last name and an amount paid by the person who has that seat. And then there are these methods. This is the method you use if you want to reserve a seat. It assigns a name and the amount paid. This is the method you use if you want to release the seat for somebody else. This is the method you use if you want to figure out if a seat is empty. And this is a method you can use to print out the status of a seat. It prints out the first name and the last name and the amount paid in a particular nice string format here. And then you can create an instance of a seat. This here creates an instance of a seat right here. And you build up this list, and so we have 5 instances of the seat, and then we assign them and so on. That encapsulates everything we've learned so far from 9.1 to 9.5. And next, we're going to learn more about the initialization of objects when we create them. That's in 9.6. So let's start with that. Class constructors. This __init__ method executes whenever you want to create an object of this class. In this particular example, we have an object which looks like this keeps track of a race time, like a running race. And so this race time object which stores a particular race time. It contains three attributes, it appears, a start time and an end time and a distance for the race. And here we are creating instances of the race time. And, let's say we're going to keep track of Jason's race time, and we're going to keep track of Bobby's race time. And so we initialize these objects, and instead of like initializing the object and then doing assignment statements, we can just do those we can combine those assignment statements and pass the values in as arguments to the init method. So there's this init method, and it's got the self identifier, which it always has, but then it's got three more parameters that come in with it, and those parameters can be used to assign the attribute variables, the internal attribute variables. So here's an example. The race time, let's say we have these have many more parameters for a race time. It's got a start hours, a start minute, end hours, and minute, and a distance. Okay, so it's keeping track of race time in hours and minutes. How would we do it up here? How do we do it? Okay, we do it this way. Well, it's better to do it this way because then it's easier to, if you want to figure out the elapsed time, it's easier because you have the hours and the minutes. You can do the subtraction and so on. So, if you want to do math. So there's like 5 attributes to a race time, and this is how you can just initialize them right off. You pass them in as parameters, and then you just do the assignments inside here. Instead of assigning a value of 0 like we did in previous cases where we initialized them at 0, here we are actually expecting values to be for assigning those internal attributes. And then we have a print time here that's able to calculate the actual time by subtracting the end time by the beginning time. And so we've already separated out the minutes from the hours, and it allows us to do that pretty easily. And then this prints out some information about pace. Oh, the pace, yeah. And so here, we have to check if this is all doing the math of figuring out elapsed time from hours and minutes. It's not just an integer where you can subtract 2 integers. You're subtracting this thing, which is hours and minutes. You're subtracting that from this other thing, which is hours and minutes, and you have to, the subtraction is more elaborate, as you can see. All right, so so in this example here, we have a class called race time, and then we have some distance value for a race, I suppose, and then we ask the user to enter in the start hours and start minutes, like 6 hours. If it starts at 6:30 in the morning, it'd be 6:30, and it ends at let's say, I don't know how long. This is 5 miles. I don't know, some other hours and minutes, and then we create an instance of this race time object, and so we put all those parameters in there like that. These are on this side, and this side these are called arguments. So we put the 1, 2, 3, 4, 5 arguments in, and those are arguments to the init method. These arguments here, and they're assigned. Now, why are we doing that in this case? What's the purpose of it? Well, it's real easy. Since we have this race time object, if we want to print out, we have the start time and the end time, and we want to print out the elapsed time or whatever, we just stick all these values into this race time object, and then we got these methods here to print out the information that we want. We print out the time, And that invokes this method here to return the time to complete the race. So here are some examples of some executions. It starts at 5:30 in the morning, ends at 7 o'clock in the morning. The time to complete the race is 1 hour and 30 minutes. And the average pace, in other words, the minutes per mile, is 18 minutes per mile. This person did it a little bit faster, shorter time to complete. And the minutes per mile is less, faster pace. All right, so so this section here is about constructors. Write a definition of a constructor method that requires the parameters x and y. Well, I guess it'd be def init, and then you got to have the self thing, and then you could do x and y, I suppose. Is that right? Yeah, that's right. Complete the statement to create a new instance of a widget with this. Well, that would just be, widget, parentheses, 15, comma, 5. Yeah, like that, I think. All right. Okay, so now, great. Now you can have default parameters. So here, if here you have to pass in a name, but if you don't pass in a wage and you don't pass in an hours, then it uses the defaults, okay? So here, for example, it's going to use the default wage and hours. Here, it's going to use here it's going to actually use a different wage and a different hours. Now, I don't think you need to say it. I don't think you need to do that because I think it's positional. But anyway, we'll get to that. There's all kinds of ways to specify the arguments of a of any method. These kinds of things work with any method that you define. All right, so this just prints out a list of them all. Default constructor parameters. So this gives some defaults here. Name has got to be there. The others, what does this say? Oh, I see. So you go through this and you see which one applies for which one of these. Okay, so let's take this one. Tommy. The name is Tommy. So that'd be either this one or this one. The self grade is 9. That could be this one. The honors is false. It's this one, and the honors is false. Okay, so it looks like this is all the default. This is the default. This is the default. This is the default, and the name is Tommy. And so this one will work. Yeah. So anyway, that's this. So make sure you go through that. Constructor customization. Okay, so you got these constructors like that, and that. Okay, let me just. Okay, you're supposed to say the first time it prints the length of 1, the second time it prints the length of 2. So we're only printing length, so we're only printing the first one. So the first time it prints 2, and the next time it prints 8. Okay, here now, for the second one, we've got some defaults here. And so the first time we are actually overriding the defaults. And the second time we are going to take the second default, but override the first default. And for the third one, we're taking all the defaults. So what's the width each time? Well, the first time the width is going to be 4 because we're overriding it. The next time we're going to take the default width and, oh, tricky. Look at that. We print out number 2 first. So we print out the defaulty one first. Clever. So 6 is first because it's this one, and width is not specified, so it's the default. Width is the second, would be the second argument. There is no second argument, so it uses the default here. Okay, the next one is number 3, which is going to be the 4. So this is 4. And the last one is the width number. No. 3 is this one. Okay, 2 and 3 are both the defaults. And the last one, which is rectangle 1, is the only one where the width is specified. So the width is specified 4. Enter. Okay. Width is specified in 1, but not in 2 and 3. First you print 2, then you print 3, then you print 1. So the only one where the width is specified is 1. I think this is right. Yeah. All right. What's next? Defining a class constructor. Well, let's see. What is this one like? Okay, so we're going to define a class constructor here. So num mins and num messages, default value of 0. One plan was created with this, and another plan was created with no input, and the third plan was created with an input of 500. Okay, so you might have noticed that, no, never mind, we aren't there. We aren't that far yet. All right, the constructor might look like this. Default, define, init, self, comma, and the first one is num mins, and num messages. And we got some defaults here. I'm going to set the defaults here. Yeah, that's right. Set the defaults here. And then I need to do I say num, oh no, self num mins equals num mins. Okay, now this is actually defining an attribute of phone plan called num mins. This is just this. So if I were not, I mean, I could call this something else, and then that I would have to use that same name here. Okay, this doesn't necessarily have to be the same as this. Okay, it's just convenient. But whenever we refer to an object's number of minutes, we use this. Okay, hope that makes sense. Just like we don't have to use self, we can use any variable. It's just that whatever we use here has got to be used here. Okay, so so this takes care of that one, and then self num messages. And by the way, that's why it's a different color. That's why this thing makes it a different color. And of course, what I don't like is for people that can't distinguish colors as well as others, you know, that's meaningless. I have a lot of friends that are colorblind. I'm not colorblind, but a lot of my friends are. All right, so that should take care of that. Okay, so then what do we do? Reads in that. Dad's plans. Well, I don't know. Does this work? What did I do wrong? Okay, so it's good to for me to go through these error messages so you know what they mean. Okay, phone plan object has no attribute called num messages. Well, I must have called something num messages. Oh, here we go. I called it num message, and it, oh, what does it say the attribute should be called? It should be called num messages. Okay, so I guess this has got to be that. I think that'll just fix it. So on line 12, this is line 12, it's this one. It tries to print num messages here, and there is no num messages. And this was already there. So this has got to be the same as that. Now, of course, I wonder if I could, well, I'm not gonna, but this has got to be the same as that because we're actually using it here, and here we're defining it. So that's my error. So that's on line 12. It wasn't able to do that. And earlier up on line 20, that's where print plan was called. So first print plan is called here, and then it comes to here, and this is where it gets bungled. Okay. And the reason is this wasn't defined because this was called something else. Anyway, so now it should work. Okay. All right, class interfaces. So here this is kind of a summary of what we've just done. A class usually contains a set of methods that a programmer interacts with. So it's the set of methods. That's sort of how the programmer sees the class. There's attributes, and then there's these methods. And the class interface consists of the message that a programmer calls to create the class or to create the object, to access certain attributes of the object, and access or a class instance. Create or access a class instance. Okay, or access, yeah. The figure below shows a class interface for race to the race times class. So this is, we see the constructor, which we can pass in 3 parameters. We see the print, this thing, which we can use to print out the time, and we see this thing, which can be used to print out the pace. A class may also contain methods used internally that a user of a class need not access. For example, consider a race time class that has a separate method called diff time. Okay, so imagine in this, let's say that instead of the way we had it before, is this, I don't want to click back, but let's say in our race time class, the interface that the user sees, the class interface that the user sees, is only print time, print pace, and then of course the constructor. That's print time, print pace, and then of course the constructor. But there may also be some internal methods that are of no, that the external programmer need not know about. And so the convention is, so these are like private methods. And so the convention that this book suggests or promotes, and probably all Python programmers do this, if it's a hidden method, if it's a method that is not intended to be used by the programmer, the name of the method starts with an underscore. That's so when you're looking at the class, you're looking at the documentation of a class, you want to use it and stuff, and you see these other methods here, you say, okay, well, this is a method that's used by other methods inside this class. And lo and behold, it's used here and it's used here. Now, in Python, there's no way to enforce the hidden nature of a method, okay? In other languages, there is. Like in C#, you define private methods and you define public methods. And same with attributes, just variables. You define private variables, private attributes, and public attributes. And then, the language enforces that. But in Python, it's not enforced. So in fact, the user can use this method if the user so chooses. The user shouldn't, though, because the owners of the class, let's say someone else is responsible for maintaining this class. They decide they want to do something differently, and they decide to do away with this. Well, they have every right to, because this is not intended to be used by the external programmer. Anyway, that's just a point. Okay, so here, so that's the point of this this section. And so we go on and we define some more terms. Abstract data type, which is a data type whose creation and update are constrained to specific well-defined operations. Okay, so you know, so it's you really should only use, when you're using the race time class, you really should only use these methods, and you can use these attributes. Now, it turns out that in a lot of classes, they're even more strict than this. They don't really let you add any of the attributes. Everything is through a method. So you'll have a get method, which is where if you want to get out the value, let's say you want to get out the distance variable, if you want to get that value, you don't just refer to the object name dot distance. You have a method which retrieves it, and in that way you make all the attributes private. And the only way you can get at attributes or do stuff with attributes or change the value of attributes is through some methods, some defined methods. But in Python, it's a little bit more relaxed. We don't really necessarily do the get and set methods, which you find so common, which is common in languages like Java and C#. We just access the attributes directly. All right. But anyway, that's this concept of an abstract data type, and you define when this class is used, you only use these methods, and you don't use these other methods, and so on. All right. This goes on to class customization. There's other special methods which you can override, you can redefine, or you can augment. So you can have what we say are infix operators can do more things. Let's see. So what's this? Normally, let's say you've got a class, and you got a whatever, and you create an object based on the class here. You got this object, and it's got these parameters, these values, and then you want to just use this print function. You can do that, right? In Python, you just print out anything. It's going to print out something which tells you what's going on. And so when you do this on this object, it's gonna say it's going to print this out. And this is actually probably the physical address, the hex address of the object, where the starting point of the object is. And you see it's of the toy class. It's a toy class instance. Class is the main program. Toy class instance right here, and that's built into Python. Well, what if you want to print something? What if you want that built-in print method? Maybe you want that to be more elaborate or be more meaningful. Well, you can override this, and the way you override it is you define. This is going to be an overridden method of in the toy class, and since truck is an object of the toy class, then this will apply to truck. And so here we're redefining the print, and this is how you do it. You redefine the __str__ method. Okay, so here we're redefining this default name for the method to print out this instead. It prints out all three of these things. It prints out the values. It prints out something that looks like this. So now when you say print truck, it's going to print this out. You've redefined this method, doing the same thing, but you've redefined it here by redefining this internal method for the print function. Okay, so that's the built-in print function. but there's a bunch of other built-in ones you can do. Here's some more on that. Operator overloading. You know, normally these operators only work with certain kinds of types, like, you know, numbers or something. But let's say you have this class, this time class, where really you're storing hours and minutes. You're storing hours and minutes, okay? And you have objects that are that were created from the time class. Do we have anything like that here, or is this just too fancy? Class time, I don't see time. Here. Oh, here we are creating a time object, and this is the hours and this is the minutes, and we're appending it onto this list of times. So we have a list of times like this: hours, minutes, hours, minutes, hours, minutes. And let's say we want to define, you know, let's say we want the minus operator to work on this. Let's say we want to be able to take this time minus this time and actually get, you know, 1 hour and, you know, 35 minutes or whatever this minus this is. Okay. Well, you know, the minus operator is not defined for this special object, that special class. Well, we can define it. In this example here, we've redefined the print and we've redefined the less than operator. See, so that means that we can say which one is greater than the other. You know, this is greater than that. And so, but it's complicated. You know, we can't just look at the hours because maybe the hours are the same and we have to look at the minutes. So that's what this function does. So here we're redefining the less than, you know, that operator. And so here we can use it. See, this is a time object because we're doing, you know, we're looking at one object or one item at a time out of this list of times. And we want to see if this time object is, you know, less than this time object. And so we have redefined the less than operator this way. Okay, so that's another thing you can do. Class customization. I don't know when you're ever going to do that, but, you know, you may do that sometime. So you should go through this to make sure you understand that. Here you're redefining the print function. And so when you do this, it's going to print out the hours, then the minutes, hours, the minutes, just like that, hours and minutes. So anyway, you can make sure you can do that. All right, so it's 1:07. I'm going to do some more of these. Okay, so we've gone far enough into the chapters to be able to do the labs, I think. You can go through more on operator overloading and then this memory allocation. You should go through that. Let's do 9.12. Okay, so I'm going to do a REPL. Let me go over here and Teams ITS128 and create a new REPL, Python, and I'm going to name it this. And let me copy all this. Put it here. Okay. And then I'm going to, is it give me some starting code? Yeah, I guess it does. Make sure we got the default template. And I'm going to copy this. Copy. All right, here we're supposed to define the constructor for the food item with parameters to initialize these instance attributes. All right. So let's just do that right now, since we don't need to look at anything else. That's enough of a comment there. Define underscore, underscore, underscore. Oops, no, just 2 underscores, right? Init. There we go. Self, comma, blah, 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 blah. These thingers. And there we go. What? Why are this? Why are those? Oh, there we go. There we go. Okay. Okay, so the first thing we're going to do is self name equals name. Self fat equals fat. Self carbs equals carbs. Carbs. Self protein equals protein. Okay, so, and of course this, yeah, you see when you click over that, it's telling you these are the same. It's not the same as this. This is the same as this, which is the same as this, you see. So they can be named differently. All right. So what are we supposed to do here? Complete the food item class by adding a constructor to initialize the food item. The constructor should initialize the name. The name should be initialized to 1 or to none, and all the other instance attributes to 0.0 by default. All right, so let's do that. I'm going to do this is equal to none. I think I just do this. I think that's what I do. Huh? Does that work? Or do I do quote none? No, maybe I do quote none. And then, what is it? And not like that. Okay. I think it's squiggling because defaults really should. Let me see if I'm right. For there not to be squigglies ever, you got to start with the right side, because the way all your parameters that have defaults have got to go at the end. Okay. Because if you put them earlier, it doesn't know it won't know the order of the parameters. Well, you know, use. Okay, let's see if I'm right. 0.0, that's fine. So it means you can define this and define this and define this, but if you don't define this, it's defaulted. If you were to make one of these here earlier be something where if you didn't define them, it's a default, then like let's say you did this. The reason it's squiggly now is because let's say you when you're passing parameters, where do we use it here? Here we're passing parameters. How do we know if the first parameter that's passed is a name, is for name, or it's for fat? How do we know? Because if it's not name, it's going to be none. If it's fat, you know, if it's fat, then its name should be none. But there isn't any way for it to tell. The only way that it can tell if you're going to use the defaults if it is at the end of the parameter list, if it's at the end of the argument list coming in, but there's more parameters. Those remaining parameters better have defaults specified for them. Otherwise, that would be an error. So anyway, so as long as we put something for the rest of these, then the squigglies will go away. Okay, so now the squigglies have gone away. Is that all we have to do? If the constructor is called with a food name, grants that constructor should assign each instance an attribute. Given the program accepts as input a food item, name, fat, carbs, and protein, and the number of servings. The program creates a food item using the constructor's parameters, default values, using the input values. Number of servings. There must be one more. Where does number of servings go? Oh, calories. Okay, when we call it, how do we know? All right. Is there a default for number of servings? If the given program accepts as input the food item, name, fat, carbs, and number of servings, the program creates a food item using the constructor's parameters, default values, and food item using the input values. The program outputs a nutritional. Right. I think number of servings is a variable that comes in here. So I don't need to have number of servings as an attribute to a food item. That's not an attribute to the food item. So I think I'm done here. Let's see. Do I have to? I don't know what this is. I want to just do that. It doesn't look right. Yeah, this doesn't look right either. Okay. Let's see. How does that end up looking? All right, that looks pretty good. All right, I'm going to run this and see what happens. Oh, I'm asking for things. I'm going to put something in here because I know what's going on. Name, fat, carbs, and protein. Okay, so it asks for those things. Oh, here it's asking for a number of servings. And are there any other inputs? No. Okay, let's run this and see what happens. So I want to put in this data up here. M and M's. 10.0. 34. I'm just going to do that. 2. 1. Nutritional input per serving. 1 serving. 0 fat. Huh? Whoa. It's nothing. What's none? Oh, I know. What we're doing here is we create an instance. We ask food item 1. Oh, I see. The first food item is creating an instance of a food item with just the default parameters. And the default parameters are none, 0, 0, 0. That's why the first one is none, 0, 0, 0. But then when we ask for all this data, we're actually creating a second food item too, with those arguments. And then it actually prints out something. So it prints out 10, 34, 2, and 234. All right. So anyway, I guess I kind of gave you a lot there. Let's go to the next one here. 913. Okay, let's create a REPL. Copy. All right, first I'm going to put all this in here. Comment. Up at the top. And I'm going to put starting code. All right. Let's see. Define an artist class with a constructor to initialize the artist's information and a print info method. The constructor should by default initialize the artist's name to none, the years of birth and death to 0. And the print info should display the artist's name and the born year, the born year if the year of death is dash is -1 or the artist's name otherwise. I'll understand that when I see the examples. Define the artwork class with a constructor to initialize. Oh, okay, so now we're going to do an artworks class. We're going to do an artist class and an artwork class with some defaults, and use the artist default and the artist to use the I think I'm missing some italicized things or something here. Okay, I don't think that got in there, but so anyway, okay, so first of all, we're going to we're going to create an instance of an artist. No, we're going to ask an artist name, birth year, death year, title. Well, okay, the first thing we're going to do is we're going to create a user artist with artist name, birth year, and death year. Okay, here to do, define a constructor with the parameters to initialize instance attributes, name, birth year, and death year. All right, okay. Def init self, comma, name, birth year, death year. Now, I think this thing has got probably going to have some defaults, but I'll say self.name equals name, self.birth year equals birth year, and self.death year equals death year. And then I got to do a print info method. And it's going to be a def print info, left parentheses self. And so I think what we're going to do is this default, I bet, is equals -1, because that's if there is no death year. And what is, now let me it's always going to have a birth year. Okay, so what does the print info do? It prints Okay, so it's going to look like this. Artist is going to print print. I'm going to use this way of doing it. Artist. Artist name. Born. Space. Born. And then I guess I'm going to do, how does it look? Oh, it just looks like that. Oh, okay. Quote dot format self name, self birth year, and then I got to do comma and equals, I don't want to if death self death year is not equal to -1, then I want to, oh, I don't need parentheses, do I, in an if statement in Python? If that's true, it's not equal to -1. That means it's equal to something. Then print oh, shoot. I got to print it differently. All right. All right. If it's that, it's just going to be born. If death year is not equal to -1, then it's going to be, I want to print parentheses that the death dash born year dash death year quote dot format self born year and self dot death year. Okay, birth year, I mean birth year. So I only want to go the artist's name here up to there. Print the artist's name. Followed by a space. Oh, wait a minute. Here the artist name's got to have a comma. All right, I got to do it this way. I got to take this out of here. I have to actually put this down here. That's what it looks like if the death year is not equal to -1, then I got to print both the artist name, the birth year, and the death year. Otherwise, let's copy this. Otherwise, I print else. I print this, but I print comma born, like that. And I just do this. So that's the print info. I need to pass, and then I've got artist name, birth year, death year, and then this has to do with the artwork. So I'm gonna comment this out. You can finish this part. I've done the first part for you, and you can do the artwork one. So I'm commenting that out. But I'm doing this first one. It's a little bit more difficult because there's 3 of them, and then you can do the second one. But so I'm just going to see if the artist part works here. Okay. So let me. Do I have all the artists? So I'm just doing the artist class. Constructor print info default. The name is none. Okay. There's going to default. Name is none. Years of birth and death to 0. Oh, I see. I initialized both these things at 0. And this equals 0. And this equals none. Something's not right here. Okay. Oh, I see. You actually do. Oh, you do input a -1 for the person who hasn't died yet. Okay. All right, let's run this thing and see what happens. I wonder if there's a good way to get this to start. What if I do this? Am I missing something? I think I'm missing something here. Artist name. This is birth year. And this is death year. And so let's start this again. All right, name. Let's do this one's up here. Pablo Picasso. Pablo Picasso, 1881, 1973, and it should. Oh, I left out the print info. Where's print? Oh, print info. Oh, okay.
Hi, Professor Halverson.
Hi, hold on. All right, so we need to actually invoke the print info. I don't see in this code here that the, oh, here we did. This invokes the print info for artwork, but I don't see invoking the print info for the artist. So I'm not sure about that, but let's do that though. After we create this user artist object, and then we're going to say user artist dot print info. Okay, now let's see if it works. Let's run this again. And I'm going to say Pablo Picasso, 1881. And when did he die? 1973. Oh, I was alive then. 3. And it prints out that. Now let's try one where the name is where the person is still alive. So let's run it again. And the name is Bryce Marden, 1938, and still alive. And it prints it out this way: Bryce Marden, comma, born 1938. Okay. I see. In this assignment, you don't need to do this because once you complete the artwork portion, the artwork, one of the attributes of the artwork is the artist. And so the artist here gets connected to the artwork. And so when you define the constructor for the artwork, which you have to do, the artist is actually going to be an object. It's going to be an artist class object. Now that doesn't really matter to you because you can just write the constructor anyway. In fact, I tell you what, I'm going to do it for you. Let me define the constructor, define init, and self, comma, and these things. And we say self.title equals title, self.year created equals year created, and self.artist equals artist, like this. And define the print info as what does it look like when we print it? It prints the artist and then the title. The title. Okay, just prints the title. Okay. So this print info method does this. It's a print def print info. Got to have the self in there. And what we're going to do is the first thing we're going to do is we're going to artist. This is this artist, self.artist, sorry, self.artist. This is a, it's an object of the artist class because when this is created, what is passed in here, and I can take these comments out now. A new class called a new object called new artwork is created from this class, and this user artist is a object of the artist class. So that's why this just ends up being passed in. It's an artist object, and so that gets passed in. Now I've left this one in here. I'm just going to leave that in here. So after the artist is created, the artist object called user artist is created. We print out the information on it, and then we go ahead and we create some artwork that was made by the artist, and then we print out the new artwork print info. In this assignment, when we print out the artwork, when we do the print info for the artwork, at that time it prints out the artist plus the title of the artwork. So in our little program here, we're going to see this line printed out twice because I printed out here and then I go ahead and create the artwork. And then when I call this, I'm going to be printing it out again. So self.artist dot print info, that is going to print out the info for the artist. And then after that, we want to print, what are we printing? We're printing title colon that. Title colon, that's the title, followed by the actual a comma and then the year. Comma and then just the year. So what is the year? That's this one, self dot year created. I'm being stupid. Comma there. Dent dot format. This should be a quote. Dot format of self comma a self dot title comma self dot year created. Okay, so first we print out the artist information, and then we're going to print out the title followed by the year created, and that's what this is here. Title, this is the title, comma year created. That's this. All right, so so I'm just going to run this and see what it let me know what I'm year created. And this is the title of artwork. I'm going to put that there. Okay, they're all okay. Now I'm going to run it. I wish I knew how I could get this thing to run right away. All right. Name, Pablo Picasso, 1881, 1973, 3 musicians, which he created in 1921, I guess. And we print out. Now this is printed out once just because I do this here, just because I printed it out prematurely just to see that it worked. I guess I can comment that out. You should probably comment that out because you only wanted to print it out once. But then down here, so then the artwork is created, and then down here, we print that out. And when we print out the artwork, the first thing we do is we call this print info here, prints out the thing again, because we just called it earlier. And then we print out that. So this is really what the output should look like. And we see that's correct. Let me do this for you. Actually, I shouldn't comment this out. And let's run it again. And let's use this data here. Bryce Marden, 1938, still alive. Distant Muses in 2000, and we see that Bruce Marden, born 1938 to 2000. All right, well, so we've done 913, and so I will end it here and continue on with 14, 15, and 16 in the next video. Thanks for watching.